So we are going to, so the goal of today is we will end up with an experiment. It's not going to be the whole class. It's going to carry a lot over onto Friday. On Friday, you will be running your own experiment of something. You'll be designing one of your own experiments. So we're doing one together today, hopefully, and then on Friday, you'll be doing one yourself. And remember, you're not here tomorrow. Do not come here tomorrow. So these are going to be our main 4 things we're focused on. You don't need to write this down right now, but we're looking at the difference between an observation and inference. And if you're like, well, what do those mean? We'll figure that out. We want to figure out what a control independent variable and a dependent variable is. We will go over those explicitly. We're going to look at the scientific methods, and then we're going to look at different types of systems as well. These are going to be our vocabulary parts here. As you can see, you probably know a couple of these, but some of these are going to start to become unfamiliar to you for sure. I would argue many of these would actually be unfamiliar. So that's where we're kind of going to end up here. Now, before we go into that, if you remember from yesterday, what does all science kind of start with? It starts with a Q. Question. I have a question about something, right? You know, which cleaner is better for a floor? You know, for example, that could be science. You start with a question, and then you gather data, and it has to be good data, right? Like what makes data good?
Valid.
Sorry? Valid proof. Well, that's what we try to use the data to prove in our arguments. Usually we want to have an unbiased person doing it. So we want the data to be unbiased. So you have someone who's, you know, they're not going to try and manipulate the data, for example. If I go outside, like, if I go outside of a Trump rally, who are you going to vote for? That's unbiased, right? Like everyone's, go Trump. Oh, polls say, 99% of people in the country are going to vote for Trump. It was an unbiased sample, right? You want to have enough people. You want to have a diverse set of people from various locations. So we're going to be implementing some of that stuff in here today. So we have a lot to do today. So we're kind of going to jump straight into it. Yeah, here we go. So, oops. So this is kind of what we're doing today, just so you know. So we're going to start out with, we're going to come straight into, we're going to read this stuff. We'll have that section check. But that's not like we're not going to focus so much on that. Like I said, we want to get away from the book. We want to start doing some stuff. So we'll still do the same stuff. We got to read some of that stuff. We have to get some background information, but then we're going to dissect it a little bit, specifically because we're going to be doing this stuff. We have to have a good understanding of like all these variables. So my hope is that around 2 o'clock, if not even earlier, we're going to start doing it. We're going to start going over some of this stuff. And then at 2:30, we're going to start that experiment. So we're going to set the experiment up. We're going to let it start running. And when we come back Friday, we can start checking on the results. So I'll let you guys get straight into that. So you're able to grab one of those textbooks in the back. You're going to read section 1.3. And then for the online students, your e-textbook should be finalized today. I've sent the information I need, so I'm going to do that right now. Okay, so here's our vocabulary. So let's cut out on the notes as much as we possibly can. We've already kind of established this. We know that we need to observe stuff. We don't need any of this. But basically, again, all science starts with a question. You're curious how something works. All science starts with a question. That was something we covered yesterday. We know what observations are. That's fine. You don't need to write that. So let me see. Yeah, and so one of the key things here is a new one called inference or inferences. Basically, we take what we know and we take what I've learned, and then we try and come up with a solution. So when those solutions, those conclusions are inferences. So again, I will put some more concrete examples of this later today, so to make some more sense of it. But the conclusions are called the inferences. So again, we know all science starts with a question, observations, but the big takeaway from this one is just what an inference is. The conclusions are the inferences. Okay, so one thing we eventually saw is we saw this. I know it's a little blurry here. We saw the scientific method here, and really where I know it's hard to see. I'm going to go to a different one that's a little bit easier to see in just a second, but this is just the one that you'd seen in your textbook. But basically, we saw something, we got a little curious about it, like, how come the water's turning green when this thing happens, for example? So you're going to come up with a hypothesis. I think maybe it's this, I don't know, algae that's coming from the bottom of it. You know, I'm coming up with a guess, right? An educated guess. So I'm going to design an experiment to test that hypothesis. I'm going to do the experiment. I'm going to check the data. I'm going to look at the data, and I'm going to see, did my results match what I expected, or are they completely different? If I add more of that algae to a pond and it gets greener, oh, okay, that seems to make some sense. So again, this will make more sense here when we do our experiment. But again, there's a bunch of different scientific methods. But it's really, you're asking the question, you're applying what you know, you create a hypothesis, you're going to test that hypothesis, you're going to look at the results, And then if those results show that, hey, my hypothesis is true, perfect, you're good to go. But it might report that your hypothesis was not entirely true. Like, oh, I added more algae and it turned the water red? Huh? That doesn't make sense. I need to go back up here and see if I can adapt that to make more sense of it. So this is it in a nutshell, right? What's a question? Create a hypothesis, run an experiment, look at the data, and then you either run it again or it matches. I don't. The only one you're really going to need here are those top two. So we know what a hypothesis is. It's a testable explanation of a situation. We also know that when we have something, remember, for it to be science, other people need to be able to repeat it. So usually there's multiple investigations. And if everyone's coming up with similar results, it starts to become more accepted. So again, big part is you have to test it multiple times. So we're going to eventually end up conducting an experiment. I don't think we need to really write down what that is. We know what an experiment is. We test the hypothesis. The two big things here, though, is we have a controlled group and we have an experimental group. So think about it this way. If you want to test a drug, hey, I think this drug causes fat loss. I'm going to take two groups, 50 people each. They're going to eat the same thing. They're going to do the same amount of exercise, but one group is going to have this pill every day as well. The other group will not have the pill. If the group that's taken the pill loses a lot more fat, oh, I think I'm onto something. I think this seems to work. And if they lose the same amount of fat, nope, doesn't seem it does anything. But the key thing here is you have to have that control group where it's used as the comparison. So yeah, the big ones here are the control group and the experimental group. So we'll end up implementing that. So when we have a controlled experiment, we can only change one thing at a time. I can't have my group and like I gave them a fat burning pill and I made them eat less calories. The diets have to be the same. The exercise have to be the same. Only the pill has to change, right? So only one factor can change at a time. And so we have three different things that we can have as factors. We can have an independent variable. This is something that might affect the outcome of the experiment. This is, if we're talking about that fat burning experiment, this is the pill. Sorry, this is not the pill. This is the fat loss. The dependent one is the pill. This might change. And then finally, we have a constant, which would be, you know, maybe the diet and the exercise. So our independent factor here would be the fat that they're trying to burn. The dependent factor would be this pill that I'm saying, hey, this is a magical fat burning pill. And then the constant is, well, they're dieting okay and they're doing some exercise. Okay, there. Everyone's good. We have two different types of data. The only ones you really need to know here is qualitative versus quantitative data. So quantitative is a number. Qualitative data is what our senses detect. There's no, so if we talk about the pain scale, my 6 on a pain scale might be different than your pain than your 6 on a pain scale, right? So maybe you're thinking, you know, what I think is really painful, you might not think is painful at all. So that's where I'm trying to be a little more qualitative. But something like the temperature is quantitative. We're almost done. Okay, so qualitative, quantitative data. Now how do we use them? Actually, well, no, we'll talk about that later, actually. So we don't need to know about this stuff. The only things we really need to know here is like the metric system is used just as a standard one. And then we have something called SI units. These are international systems of units. These are used for consistency and ease of temperature. For example, temperature, they would use Celsius. For distance, they would use like centimeters, for example. There's just some standardized units.
Tomorrow?
No school tomorrow.
Okay, see you on Friday.
You betcha. I think that might be it. Nope, we're good there. Obviously, we analyze the data. We report our conclusions. We're going to write that down. And you know, and be safe. Okay, so we're actually going to do an experiment up here. So those of you online, you can either use Microsoft Word, you can use paper. There should be a form as well up there. Let me just load that up here for you. Yes, okay. So there's a scientific method worksheet here on the bottom in the study of life. So it's the bottom PDF. You click on that, you're going to end up with this. I'm going to pass that out to you guys here. So we're gonna do an experiment here together. We're gonna start at least. Hopefully we're gonna start it. We're gonna do pretty close. We might have to deal with the paper stuff later. Yeah, exactly. Okay. Oh my gosh, where's my mouse? So we have a scientific method worksheet here. So what we're going to do is we're going to do a got red. We're going to do a banana agent experiment. So basically, has anyone ever left a banana in like a bag? Like maybe you brought it for lunch, you didn't eat it that day, you go and look at it the next day, all of a sudden it's turned just black and brown. You know, how come it does that, but the ones on the counter are totally fine, for example. So what we're gonna end up doing is we're gonna look and see how does a banana age? Because I want to be able to store them so they last as long as possible when I want that. But I also want them to be able to, I want to be able to, if I want to rapidly ripen one, I can do that too. So what's the problem here? What's the question is the key part here. Everything starts with the question is, how can I control how fast a banana ripens. Because the bananas I bought are pretty green. Maybe I want to be able to eat one tomorrow. And I don't know about you guys. I hate like unripe bananas. So this is our problem. We're trying to figure out how fast a banana ripens. So what's our hypothesis? Well, what we're going to try and do is we're going to expose our bananas to different temperatures and different ways of storing. Some of it will just be out in the air. Some of it will be in plastic bags, airtight plastic bags. Because hey, we just said, sometimes I leave my banana in my lunch bag and I come back a day later and I can't eat it anymore. Maybe the types of bags affect it too. Which one of these is more breathable? Probably the paper, right? So is that going to change how this works? We could also repeat this with bread. You'll have the chance for that on Friday if you wanted. That's one possible experiment. Bring that back up. So that's what our plan is going to be. So my hypothesis is, if you're putting a banana in a warm or a cold environment, which one do you think is going to make it ripen faster? Probably warmer, right? So we're going to look at temperature, but we'll form a proper hypothesis for this. Also, if I store a banana, if I put it on my counter or I put it in a bag, which one of those do you think is going to ripen faster? Counter. So we're thinking maybe counter or the bag. So the storage location. So the storage temp. Actually, I'm not even going to put storage location. I'm just going to put location. So there's two things here that we can really look at. So let's turn this into a proper hypothesis. When stored in a warmer environment, bananas will ripen quicker than a colder one. That seems fair, right? If I throw a banana in the fridge, I throw one beside my furnace, one of those is going to get ripened quicker. And let me know if you can't see, I can zoom in. The next one is the location. So we're going to do this in our room here. Sorry, in the Wadena room here. So I need somewhere that's going to change. Sorry, not the location. We'll deal with that in a second. So by storage location, I mean storing bananas in a bag will ripen them quicker than open air, is what we'll say. Sorry? Light, and that's just it. Light could be it too. Absolutely. Like, there's a couple different factors we're going to maybe ignore in this case, but that could be one. I've heard, has anyone ever like you can store like an avocado beside a banana? Apparently they both ripen quicker or something. I don't know why I didn't try that one. I walked past them. I should have done that. So we have an hypothesis here, right? We have two hypotheses. We're going to actually do two experiments in one here, which is technically not a great thing, but yeah, we'll do it for the fun of it. So the materials, what do we need for this? Bananas. We need, we said we're going to test two bags. We're going to do a paper bag. We're going to do a plastic bag. And I need Well, I want different temperatures. So I'm going to use a fridge as a colder one. And I'm going to use the furnace room as the hotter one. Oh, and we need a Sharpie too to label stuff. So let's go into our procedures here. So for our procedures, these are our steps, right? Like, what are we going to do? So here's what we're going to do. We're going to prepare 3 locations: the fridge, the room, and the furnace room. Those are 3 different temperatures, right? Next, what we're going to do is we're going to put 3 bananas, right? Yes. We're going to put 3 bananas into paper bags, 3 into plastic, sorry, and 3 into plastic. So we're going to prepare our locations, we're going to prepare them in bags, and then what are we going to do with that stuff? Well, we're going to place we're going to place 3 bananas in each location. Which means each location will have an open air, a plastic, and a paper bag. So each one's going to have all 3 bananas. Okay. I'll give you a second to finish writing it down. So if you look on the next part, if you finish this, it's talking about results and conclusions. We need to now run the experiment is what we're going to do. So we've got about 10 minutes left in class here. So what's going to happen is, there's 5 of us. I'm going to need someone to put 3 bananas in paper bags. 2, 3. A Sharpie would be helpful. I mean, something to put in plastic bags. And then I'm just gonna need someone to put 3 bananas, in place. So the people with the bags, what's gonna happen is you're just gonna wanna, well, yeah, you're gonna wanna label the bags actually. So label 1 hot, label 1 cold, label 1 air. Hot, cold, and air. We also want to seal them, so we're going to give you, where's my stapler? I can give you a stapler, I can give you tape. Cold, yeah, the 1 label on each bag. And those paper ones just have to get sealed. I think I got the thing. Add tape here. Yeah, so once we have them all done, what we're gonna do is, we have them all sorted, we've labeled everything. We're gonna put them in the 3 locations. And then we're gonna kind of check up on them as we go through the next couple days.